Here I'll talk about circumcenter. Circumcenter. Now, by definition, we already know that circumcenter is point of concurrency of perpendicular bisectors. Of perpendicular bisectors of the three sides of a triangle, right? What I mean is, if there is a triangle and I draw the perpendicular bisector of this side, I draw the perpendicular bisector of another side, then this point here is known as the circumcenter. Now these are perpendicular bisectors. Okay, and obviously the perpendicular bisector of this third side will also pass through this point, which is known as the circumcenter, right? So point of concurrency of the perpendicular bisectors of the three sides of a triangle is known as its circumcenter. Okay, now this circumcenter is equidistant from the three vertices of the triangle. What I mean is that this distance is equal to this distance is equal to this distance, right? These distances are equal to each other. Okay, so circumcenter is equidistant from the three vertices. All right, so if let us say this circumcenter, if I denote it by O, and this is A, this is B, this is C, then I can say OA is equal to OB is equal to OC. Let me explain it to you why it happens. Now, from your knowledge of class 9th, we already know that if I draw a line segment AB and draw its perpendicular bisector, let us say. Now, this line is the perpendicular bisector of line segment AB. So, if this is the perpendicular bisector, what can you say about a point lying on the perpendicular bisector? This point, I have taken any general point which lies on this perpendicular bisector. Let us name it P. If I join it with this A and with B, what can you say about these two distances? These AP and PB are equal to each other, and it will be true for any point falling on this perpendicular bisector. Why? We have already studied about it in class 9th, but let me explain it to you once again. Okay, forget about these signs for a moment. Now see, this angle is 90 degrees, so this angle will also be 90 degrees, right? And this side is common to both these triangles, and this segment is equal to this segment because this line is the perpendicular bisector. So what can you say about these two triangles? These two triangles are congruent triangles. These two triangles are congruent triangles by side angle side congruence criterion. Now you know that these two triangles are congruent, so you can say that corresponding parts of congruent triangles are equal to each other. So these sides opposite this right angle will be equal to each other. Hence, this point P, which is a general point lying on the perpendicular bisector, is equidistant from the two ends of this line segment AB, or two extremes of this line segment AB. And this will be true for any point lying on the perpendicular bisector. For example, if I take this point P1, right, if I join it with A and B, this will be equal to this. P1A will be equal to P1B because of the same logic that we applied here. Because again, you can prove that these two triangles are congruent to each other because these angles are 90 degrees each. These sides are equal to each other, and this side now is common to both the triangles. Okay, so if you draw a perpendicular bisector, let us say these ends or these extremes are P and Q, then any point lying on this perpendicular bisector, this is perpendicular bisector, okay, so any point lying on this perpendicular bisector will be equidistant from P and Q. All right, I hope this much is clear to you. Now let us look at a triangle. If I take this triangle ABC. Okay, now see, if I draw the perpendicular bisector of AB and perpendicular bisector of BC, okay, this is perpendicular bisector, this is again a perpendicular bisector of BC, and these perpendicular bisectors intersect here. Okay, all right, so if these intersect at this point, let us name it O. Okay, now this point O lies on the perpendicular bisector of line segment BC, so it will be equidistant from B and C. Okay, for a moment let us consider any other point. Let us consider this point which lies on this perpendicular bisector. So what can you say about this point P1? That it will be equidistant from B and C. Why? Because it lies on the perpendicular bisector, and it should be true about this point O, right? So O is equidistant from B and C, right? These two distances are equal. Okay, so O also lies on the perpendicular bisector of this line segment AB, which means O will be equidistant from B and A. So OB is equal to OA. Okay, so O lies on, let me write it for you. O lies on perpendicular bisector of segment BC, hence OB is equal to OC. Now O lies on perpendicular bisector of AB, hence I can say OA is equal to OB. Now if you compare this equality and this equality here, we can say that OA is equal to OB is equal to OC, which means the circumcenter O is equidistant from the vertices of this triangle, right? Now if you consider O to be the center, if you consider O as your center and OA or OB or OC as your radius, right, then you will be able to draw a circle passing through A, B and C, right, having center O and radius OA or OB or OC, right? Let us denote it by capital R, right? Now this radius capital R is known as the circumradius, right? This point O is known as circumcenter, and this circle is known as the circle. Okay, this much should be clear to you about the circumcenter, that circumcenter is equidistant from the three vertices of the triangle. By applying distance formula, then you will be able to solve a lot of questions, because we saw that OA is equal to OB is equal to OC. That means OA squared will be equal to OB squared will be equal to OC squared, and there may be questions on circumcenter where you can use this equality or this knowledge about the circumcenter. Now while we are discussing the circumcenter, let me discuss something more which we will discuss in geometry portion also, but let me discuss it here also, right? Now that I've got the opportunity, let me discuss it here. Okay, let us draw a triangle once again. All right, let us say this is the circumcenter, okay, and let this be the circumcircle. Let's name these points A, B, C, and let us name this circumcenter as O. All right, so if I join O with A, right, this will be my circumradius, capital R. Okay, now if I extend this AO till this meets the circle, at this point. Let us name this point as M. Okay, now what will be this length? This length will also be the radius, because OM is also the radius, right? So AM is equal to twice of the circumradius. Okay, this is O. Now look at this. If I drop a perpendicular from A to the side BC, okay, let's name this point as P, the foot of perpendicular as P. I want you to look at these two triangles. I am joining M with C here, right? Now this is the center, so AM will be the diameter. AM will be the diameter, and this angle here will be the angle in semicircle, which is 90 degrees, right? Now I want you to look at these two triangles. Let me change the color of this pen. This triangle here and this bigger triangle here. The names of these triangles that I want you to look at are triangle ABP and triangle AMC. Okay, if you look at these two triangles, this angle is 90 degrees, angle P, and this angle C is 90 degrees, right? And let me talk about another angle, this angle here. Angle B and angle M here are being made by this same chord AC, right? Chord AC subtends angle AMC, that is this angle, this angle, and this angle on the same side of the circle, right, in the same segment of the circle. So this is the chord AC which subtends these two angles, angle B and angle M, on the same segment of the circle. So these angles are equal, right? This is something that we know already. So what I am saying about these two triangles is that these two triangles are equiangular, that all the three angles of these two triangles are equal to each other, hence these triangles are similar. So what will be the similarity? That triangle ABP will be similar to triangle. Now let us look at the angles. It will be similar to, now angle P corresponds to C here, because both are 90 degrees. Let me write it here. Angle B corresponds to M here, so let me write it here, and then here I'll write A. So triangle ABP is similar to triangle AMC. If these two triangles are similar, if I consider this AP as H, because this is also the height of this triangle, right? Which triangle? Triangle ABC. H is the height of triangle ABC with base BC. Now what will be the length of side BC? I can write that this length is small a, right? This length is small c, and this length here is small b. This is the convention. This is how we write the lengths of the sides of a triangle, right? These vertices are denoted by capital letters, and the lengths of the sides are denoted by small letters. Okay. Now see, if this is A and height is H, what will be the area of triangle ABC? Area of triangle ABC will be equal to half into base A into height H, right? Now because of this similarity, I can say that H is opposite this angle B, right? So H divided by this, what is opposite angle M? It is B. So H divided by B will be equal to, now opposite this angle 90 degree, here we have got side C, side length C, and opposite of angle C here I have got this length 2r. Okay, so I will write 2r here. What I am trying to say here is, once you know that these two triangles are similar, then you can obviously see the proportionality and write this expression here, right? Because when we have got two similar triangles, we can say that the corresponding sides are in the same ratio. Okay, so from here I can deduce that H is equal to BC upon 2R. All right, now what will be the area of triangle ABC? Let me replace this H by BC upon 2R. So area of triangle ABC will be half into A into BC upon 2R, which is ABC upon 4R. Alright, where R is the circumradius. So area of triangle ABC is equal to product of these side lengths A, B and C divided by 4 into the circumradius. So what can you say about circumradius? Circumradius is nothing but ABC upon 4 into area of the triangle. Okay, so this much you should know about the circumradius and circumcenter. About the coordinates of circumcenter, I'll leave this proof to be studied in class 11th, which I'll teach you. I'll give the lecture on this separately, but in class 11th. In class 10th, you can directly learn the coordinates of circumcenter, and I'll tell you the easy way to memorize this. Okay, so what were the coordinates of incenter? Coordinates of incenter were ax1 plus bx2 plus cx3 divided by a plus b plus c, comma ay1 plus by2 plus cy3 divided by a plus b plus c. These were the coordinates for the incenter, where the coordinates of the vertices were x1 y1, x2 y2 and x3 y3. Now I'll just replace a with sine 2a, right, b with sine 2b and c with sine 2c, right, to obtain the coordinates of circumcenter. Circumcenter coordinates will be a sine 2a plus x1 sine 2a, x2 sine 2b, x3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. This is the x coordinate. Now similarly you can write the y coordinate. Let me make some space here. To write the y coordinate, I can write it like this: y1 sine 2a plus y2 sine 2b plus y3 sine 2c divided by sine 2a plus sine 2b plus sine 2c. Where what are these a, b and c? These are angles, right? Which angles? For example, this is my vertex A and this is the angle A that I am talking about. So I am taking sine of double of this angle here, sine 2a. Okay, this is angle B, this is angle C. So these are the coordinates which you can memorize directly from here. All right.